Today's video is going to be on points of concurrency, the circumcenter and the incenter. So D is the circumcenter of triangle ABC. So if we have triangle ABC right here, D is that point of concurrency. It's where all of our points meet in triangle ABC. The circumcenter is the point where all three perpendicular bisectors intersect. So I see segment ED, perpendicular bisector. I see segment DF, that's a perpendicular bisector. And I see segment DG, perpendicular bisector. So our special point in the middle there, point D, is the point where all three perpendicular bisectors intersect. It has a special property. The circumcenter is equidistant to all three vertices. So the distance from D to vertice A is congruent from the distance between D and vertice B and from D to vertice C. So it's equidistant from the vertices. So I'm going to use that property to solve for solve for x. So we have that AD, so from A to D, this segment right here is 2x minus 10. ED, well, yeah, we know what ED is, but we don't know, ED is not congruent to anything, so I don't use ED. BD is congruent to AD, so we've got 5x minus 22. And then DG again, that's our perpendicular bisector. We don't know that's going to be congruent. What we know is that AD is equal to BD, which is equal to CD. I know those three distances from D to the vertices are congruent, so I'm not going to use the other segments. What I'm going to do then, I know that AD and BD are congruent. I set 2x minus 10 equal to 5x minus 22, and we go ahead and solve for x. So I move the smaller x over to the right. That leaves us with a negative 10 equals 3x minus 22. We move our 22 over to the left. That leaves us with 12 equals 3x. We divide by 3, and we find that x is going to be equal to 4. So our first point of concurrency is the circumcenter, and it's the point where all three perpendicular bisectors meet. And our special property here is that the circumcenter is equidistant to all three vertices, which means AD is equal to DC, which is equal to DB. All right, our next point of concurrency is the incenter. So D right now, that central point again, is the incenter. The incenter is the point where all three angle bisectors intersect. So I can see here's an angle bisector because it divided those two angles. Here is an angle bisector because it divided those two angles. And here is my angle bisector because it divided those two angles. So the incenter is the point where those three angle bisectors intersect each other. The incenter, our special property, is that it's equidistant to all three sides. So from D to the side is congruent from D to B, which is the side, and from D to C to the side. So we know the distance from the incenter to each side is going to be congruent. So I look at the information we're provided with. From Y to D is 12x. Well, that's nice, but we don't know that's congruent to anything. AD is 15. XD is our angle bisector again, so that's not going to come into play. CD is 4x plus 3. So based on the fact that it's equidistant to the sides, I know that AD is going to be equal to BD, which is going to be equal to CD. We are given these two pieces, so we've got 4x plus 3 is equal to 15. We move our 3 over to get 12. We divide by 4, and we find that x is going to be equal to 3. So the incenter, remember, is where the three angle bisectors intersect. And the special property that it has is that that point of concurrency, that central point, is going to be equidistant to the sides, which is different than our perpendicular bisectors, which is equidistant to the vertices. So you've got to remember the difference between the incenter and the circumcenter, and that is it for our video.